So now we're going to do a simple circuit and solve for the current through each resistor and the voltage across each resistor. These are some simple steps for solving these problems. You want to find the equivalent resistance first, then find the total current in the circuit, and then solve for the current through and the voltage across each resistor using the tools below, including V equals IR. Remember that your tools that you can use are V equals IR, which is Ohm's law, conservation of current, so the amount of current going into a junction has to equal the amount of current coming out of a junction. Voltage across each resistor in series adds up to the voltage of the battery, so that's our loop law, where, that's our loop law. And then voltage across the resistors in parallel are equal. Also, we have the equivalent resistance equations for resistors in series and the resistors in parallel. Let's go ahead and give this a try. I have a resistor shown here, a circuit shown here. And the first thing we need to do is find the equivalent resistance. When we're finding the equivalent resistance of a resistor, we need to work, or of a circuit, we need to work in pieces. So first of all, these two are quite clearly in series. And so to find the equivalent resistance of these, we are just going to add the resistances together. So that's 6 ohms plus 1.5 ohms, which gives us 7.5 ohms. And then we can redraw the circuit and replace what's in the blue square with just a 7.5 ohm resistor. So we have the 90 volt power supply. And then we have R1, which is 3 ohms. And then we have this equivalent resistance over here, which is 7.5 ohms. And then we notice that these two are related to each other in parallel. And so to find the equivalent resistance in parallel, we're going to do equivalent resistance is equal to 1 over 3 ohms plus 1 over 7.5 ohms. And then we take the inverse of that, and that will give us our equivalent resistance of that piece, well, of really the whole circuit. So we get 2.14 ohms. So that's the equivalent resistance of the entire circuit. Using that, we can find the current of the circuit. So we know that the battery is 90 volts, or the power supply, and we know current is equal to V over R, which is Ohm's law. So 90 volts divided by 2.14 ohms gives us 42 amps. So we have 42 amps total going through the circuit. Now that I know that, I'm going to kind of work backwards through my pictures to figure out each piece. So I have to figure out the current through and the voltage across each of my resistors. And I know several things. I know that the voltage, or the potential difference between A and H is the same as it is between B and G and C and F. And so that tells us, since these things are in parallel, the voltage of R1 is equal to 90 volts. In order to find the total current that goes through R1, I can do voltage over resistance. And so I know I have 90 volts, and I can divide by my resistance of 3 ohms. So I get 30 amps. So 30 amps go through that branch. Now, because of the law of conservation of current, I know that if I had my total current is 42 ohms, and I have 30 going through R1, then I must have 12 going through R2 and R3 because of conservation of current. And then when they come back together down here, we'll have 42 amps again. Oops, I did not write amps on those. I don't know why. Those are supposed to be A's. My goodness. Okay, so now we have to figure out, we know everything for R1. So now we have to figure out the voltage drop across R2 and R3. To do that, we know the current going through them and we know the resistance. So we just do V equals IR. So our current is 12 amps and our voltage is 6 volts. So we just have 12 times 6, which is 72. Oh my gosh. I don't know what I'm thinking. Sorry, it's not 6 volts. It's 6 ohms. So we get 72 volts. And then my voltage here, IR, so we get 12 amps. And we know that 12 amps go through R2 and R3 because they're in series, so they have the same current. And we multiply by 1.5 ohms, and that gives us 18 volts. So now we know the current through and the voltage across each of our resistors. Now there are some things we can do to double check ourselves. And as far as double checking goes, we know that, for instance, the voltage across 2 plus the voltage across 3 has to add up to the voltage of the battery. And so we see that 72 plus 18 is equal to 90, which is the voltage of the battery. So that checks out. That tells us that we did things right. Also, another good thing to check is that the current is conserved, and we actually use current conservation in this one to solve for our current through R2 and R3, but sometimes you won't use that, and so that can be a good thing to use to check. All right, there it is.